Hi viewers, welcome to NCKHUB. If you like our videos, kindly do subscribe and follow us. Thank you.
We plan to create a playlist that covers all the concepts of Java 8, and as part of that playlist today we came up with a concept called Lambda expressions, which is a very crucial feature which was introduced as part of Java 8 that every Java developer has to be aware of. Let us go deeper into the concepts. Primary objective of introducing Lambda expressions in Java as part of the Java 8 feature is to promote the benefits of functional programming, because before Java 8, whenever we get the discussion of Java, we always discuss on OOPS concepts, and it is very well aware that Java already always deals with the objects, and we consider Java as the object oriented programming. But starting Java 8 with the introduction of Lambda expressions, they tried to include some features of functional programming into Java. That doesn't mean that Java will be completely a functional programming language, but they try to include some concepts of functional programming into Java. So, what is a Lambda expression? Lambda expression is an anonymous function. What do you mean by an anonymous function? The other words could be a function which doesn't have any name, which doesn't have any return type, which doesn't have any access modifier. So if you take the syntax of a traditional method that we write in Java, the traditional method syntax would be, first will be the access modifier, and then we will be writing the return type, and then we will be writing the method name, and then we will be providing the attributes or parameters as part of inputs. Maybe there will be methods with no parameters, single parameter, multiple parameters. So we will be providing the parameters as per the requirement, and then we will be writing the method implementation. That is the way we do the traditional method in Java. So the access modifiers in Java are four types: public, private, protected, and default. But when it comes to Java, Lambda expression, we need not use any access modifiers, we need not use any return types, and we need not use any name here. And what is the primary use case of Lambda expression? Lambda expressions are widely used in the combination of functional interfaces. We mainly use them to provide an implementation for the functional interface. So, what is a functional interface here? We will be coming up with a detailed explanation of functional interface in a separate video, but at the moment, what is a functional interface means? An interface which will have a single abstract method is called a functional interface. That that doesn't mean that saying functional interfaces were introduced as part of Java 8 doesn't mean that there are no functional interfaces before Java 8. There are interfaces in Java which have single abstract method before Java 8 as well. One such example is runnable interface, which we mainly use in multi-threading concepts. But they have introduced a lot more functional interfaces as part of Java 8, which we will be covering detailed in separate video. Apart from functional interfaces, Java in Lambda expressions were widely used with the combination of collection objects as well as streams APIs. Now, let us take a traditional method in Java and let us see what are the steps that we can follow in converting that method into a Lambda expression. So, as the name or the definition of Lambda expression says, that function doesn't need a name, doesn't need a return type, doesn't need a access modifier. As a step 1, we will be deleting the access modifier. As a step 2, we will be deleting the return type. As a step 3, we will be deleting the method name as well. And now in the fourth step, what we need to do is we need to include a arrow sign between the parameters and the method implementation. So this itself will be considered as a lambda expression. So if you ask me what is the syntax for lambda expression, so this is the syntax for the lambda expression. We will be having the methods parameters here that can be used as part of this implementation, which can be considered as input for this implementation. And we will have a arrow sign, and right side of the arrow sign we will be providing the method implementation. If we have to still redefine the lambda expression part here, when the implementation is having only single line of implementation, we need not use the braces. These braces are optional if the method implementation is having only single line of implementation. And here in Java, JVM has an additional capacity or additional feature of understanding or predicting the data types based on the code that is being executed. In most of the cases, JVM will be successfully predicting the data type for the input parameters that can be used or that will be used as part of the Lambda expression implementation. So even the data types before the params were optional in case of Lambda expression. It is not mandatory to include the data types. So this is the final Lambda expression that we can end up with compared to the traditional method that we have taken earlier. Maybe since it is a simple method, you might not feel much difference, but when you write the complex logics and other things, and the combination of functional interfaces, streams, APIs, you see a lot of difference with the Lambda expression usage. Now, considering the fact that you have got some idea on how to write a Lambda expression, I will take some examples that will help you in understanding what is a lambda expression and how can we use those lambda expressions in a programmatic approach. So for this one, I have taken couple of interfaces. This is one interface which I have taken. With this will have a single abstract method with no input parameters, and there is one more interface which I have taken. This is also a single abstract method, and this have two input values. Okay, so for the first interface, I have created one class here. For this class, I directly provided the implementation in the main method. Usually, in the traditional approach, you cannot provide the implementation directly. You need to extend it to a you need to provide an implementation for an interface, and then only you will be able to create an object, which is nothing but a runtime polymorphism concept. But here the concept is a little different, where you can directly provide the implementation to the abstract method, which is there in the interface directly from the class itself. Okay, here I am trying to provide the implementation. Here I did not give any parameters because this abstract method doesn't have any input parameters. So empty parameters are there here, and since it is a single line implementation, I did not include any braces. I directly provided the implementation and I directly called the method using this object. Let me try executing this program and show you the output. See, here is the output. And now let us go to the second program here. Here I have provided an implementation for the other interface that I was showing you. Here also we have a single abstract method with two input parameters. So I have provided two input parameters here. If you notice, I did not include data types as part of the params, input params. So since here also I have provided only one line implementation, that's the reason I did not include any braces. So here the implementation is the addition of two numbers should be printed in the console. And I called that method couple of times with different level of inputs. Let me execute this as well and see the output. See, here is the output. Now, let us take the concept of runnable interface and how do we use to create a object for a thread by using runnable interface. What is the implementation without using lambda expression? First, let us see that, and then I'll show you the implementation using the lambda expression. So, in the traditional approach, how do we implement the concept of runnable is we will be creating a class that will implement the runnable, and we will be overriding that run method inside that class, and then we will be again creating a separate main class that will create an object for the implemented class. Or it's not mandatory all the time you create this, you can have inner class as well. It's up to the implementation that we can plan. And once we create an object here, we will be creating that, using that we will be creating a thread and we will start the thread. This is the traditional approach that we follow. Let me execute this program and I'll show you the output. So here the main thread is there, and followed by the main thread the child thread is there. So the child thread is the one which we have here. We created a separate class that will be implementing runnable interface and we will be overriding the run method. Now come to the concept of using the lambda expression. If you see the lambda expression implementation, we are directly providing the implementation inside the main method itself. We were not creating any other class and overriding all those things. We are not doing it here. We are just directly providing the implementation at the same time where we create the object. We are not creating any separate class and writing or overriding the methods inside that class and again creating an object. We are not doing all those things. So we are just right away providing the implementation. So this implementation will in turn directly JVM will understand such a way that okay, here the implementation for the run method inside this runnable interface was provided, and they were trying to create an object such a way that whenever this object is invoked, we need to call the run method, which was there inside this. And the other remaining part of the logic is still the same. And let me execute this output. See, this is the output. So if you compare the output in both the cases, there is no difference in the output, but the way we implement it with the lambda expression, without lambda expression is the key takeaway from this concept. With lambda expression, we need not override the run method separately in a separate class or in an inner class or anything as such. We can directly provide the implementation here using the lambda expression part, but whereas in the traditional approach, we need to separately override the run method using this annotation, and then we need to create a object for that class in a main class, and then we need to make a call to that class. So lambda expression usage has simplified the logic to some extent. Since it is a simple example, you might be seeing a little difference, but going forward, if you start using the functional interfaces deeper and in a regular day-to-day coding, you will see a lot of difference. That's all for this video. Thank you very much. Please like, share, subscribe.